Here we are. Mark and Marty, you guys with us? No, I don't have bourbon tonight. I have hot tea. Having some Earl Grey because I'm still freezing. House being cold for the last 2 days. Let's see. SolidWorks here. Uh, doing. There we go. Thunder, what's up? Mark, what's up? Cram it. Marky's here too. Aw, thanks guys. Why does it say I only have one person viewing so far? Everybody's here. Who we missing? We're missing Andrews. Marty, how do I let's give Andrews a link to the live stream. I think he should get a YouTube link though, because there's no way he can handle doing Twitch. Tonight, I think what we're gonna work on is our Delta 5 timer, which I've got right here. I stopped at the track and picked this guy up. So far we got 6 nodes wired up on this one. And Cram Knitram, he's the one that's doing all that work. So you can see there's like 6 Arduino Nanos on there, and then a Raspberry Pi that controls the whole thing. And there's 6 of those RX 5808 diversity receivers sitting across here, and that's what picks up your video transmitter. So yeah, this is our like budget timers. Yeah, budget timers for the track. Marty and I were over at the track, and I was flying the tiny whoop around, and it was cool because I had the distance between the immersion timer and this Delta 5 timer measured and put into the system. So it was reading out how fast I was running from one side of the room to the other side of the room holding the tiny whoop. So anyways, we need to make an enclosure for it now that this thing is like a functional piece of hardware. And we gotta order more parts. I think we wanted to get one running first before we got too carried away. So we got this Marty got this one wired up and the board populated. Let's see. I don't think it was too bad, you know. They had to fill out all the resistors there and solder down the nanos and the video receivers. And you're kind of in business, right, Marty? Flash Delta 5's hard drive image onto this Raspberry Pi here. There she is. Yeah, there's an SD card in the Raspberry Pi that's got the disk image on it for the timer. Not as much control over this timer as there is with the immersion timer. Like the immersion timer, I can tune every single channel to make sure that I can accommodate anybody that's like overpowered or underpowered. And this one seems to kind of have like a global setting in live time that applies to everybody. So I've tested it with just with the one Inductrix. So next step is going to be like live testing this in a race with 4 people flying and see how it does. Let's see. Mark says donate button isn't clickable. Which donate button? Is that the donate button that's in Twitch right now? I was switching over the donate buttons off of the Streamlabs donate button, which looked like it kind of tied you into a subscription, which I don't want to tie anybody into a subscription unless it's to me. So I started putting up the PayPal.me links, and I know I've got that covered over on YouTube. So what do I have to look at? I have to look at over at Twitch and see if I've got that link set up properly. I don't know. The Streamlabs donate link is way cooler because then you get the animation on the screen, and that's totally worth the $5 a month, right? Anyways, Marty, did you get a link over to Andrews? Get him involved. Send him. Marty, my tea's way overdue. Hold on, my tea's overdue. It's over steeping. I'll be right back. I didn't think about this. Definitely didn't plan ahead for my tea. There we go. Oh, that's better. That's better. We don't want that tea to get I don't want that tea to get bitter on me here, right? Oh, that feels good. Nice and warm. Phew. Okay, where are we going? Over SolidWorks here.
Features for the DELTA5.
Yeah, so let's pop in and start an assembly in SolidWorks and start dropping these timers in. I want to see if I can make some improvements to the way we do this timer over the immersion one, just like physically. There's a number. Marty says there's a number of people working on some more features for the Delta 5.
Down to a science.
Fender says he has his tea steeping down to a science. Normally I'd set my little timer, and I just didn't want the timer going off on the other side of the room. I really didn't think that one through. I see that I'm way overdue. That was in there for way too long. Bad me for doing trying to live stream and keep track of my tea at the same time. We got a nice Harney and Sons Earl Grey Supreme. Delicious. And hot. Alright, how do I get a link here? Share. Let's get a share link over to our buddies here. Let's see. I'm gonna start a new blank assembly. And what do we got to do? We got to drop in some of these boards here. Got a blank board sitting here. Let's see. Uh-oh, somebody's having trouble chatting in Twitch. I see Mark is chatting from Twitch, okay. That link sent off, and hold on, Havelock. I'm gonna take a look at what you're seeing here. Let's see. This room is in 1-day followers only mode. Follow this channel. Join the community. Are you following my channel, Havelock? You definitely should be at least following my channel. Kitties, be quiet. Okay, I think there's a setting in there where if you're a guest, it wants you to sign up after so much time. I don't know if that's is that something I can tweak on my end or what? I don't know. I'm not sure. I think, but if you hit the follow button at the um wherever it is up at the top to follow the NLFPV channel, then you shouldn't get that anymore. Following doesn't cost anything. Subscribing costs something. Yeah, so subscribing to the channel, you're giving the channel X amount of dollars every month. Following the channel just means that you get alerts about like whenever the channel goes live. So Havelock, I think you just have to like click the follow button for the channel, and then the chat will be good to go again. Let's see. What kind of Fender? Circling back to the tea for a second. What kind of tea do you drink? I'm curious. What everyone else does. I know I like Earl Grey's, and I really like this smoked tea that I have, and it's not lightly smoked. It's like campfire in your face smoky, and the taste is absolutely delicious. It goes really good with cheese. But I am freezing, so okay.
Matt
Anyways,
Fender, a bunch
let's get
of
organized here.
ones. I was at Tea Leaves today.
Fender says you're out at Tea Leaves today. I should go to a local tea.
Matt Fender typically flavored
here.
greens or flavored whites.
Flavored greens or flavored whites. I like white teas. The flavored teas, I don't know. I can't take the teas that have like an artificial like flavor to them for some reason. I don't think they're artificial, but man, like some of the flavored teas, I can't get over the taste or the smell or something like that. So yeah, maybe I can hook you up with some of those teas because I've tried so many teas, and so I have boxes and boxes of tea that I'll never drink because I just can't deal with the smell or whatever it is. So I like my teas a little bit on the bitter side, not too much flavor on the like fruit side or flowery side. I need stuff that's like bitter, smoky. I don't know. I guess still more of a coffee person. I gotta have a tea break every once in a while. You get too much of that Tim's built up in your system.
Matt Fender, I didn't
it starts
like
to
it
get
until I started
to be
getting
too much.
tea. I never really found bags I liked.
Fender said he never found the bag tea that he liked. Yeah, I'd have to agree there. The problem I have with this Harney and Sons tea is that like you get free shipping if you spend like $50, and then so I end up with like like 20 boxes of tea at the house. It's too much. Mark's asking, is the King of Hearts done? King of Hearts is pretty much done. I have to make more parts for the King of Hearts, and that just isn't happening lately. I didn't have power for most of today, and I didn't have power yesterday at the house, so no 3D printing got done. And that's where we are. We have to 3D print the like top part for the battery strap, and then we have to cast the little bumpers for the feet, and then we can assemble the King of Hearts drone. So hopefully we get to that silly thing one of these days. Love to finish that thing because I want to get that.
I've drank it basically exclusively.
Get that thing out there and flying that thing because it's almost time. I see you guys are outside already. I'm not outside already. I'm not that brave. It's still too cold and muddy. Fender. I drank it basically exclusively since I stopped drinking soda about 4 years ago. Yeah, I can't take the amount of sugar that's in pop. I don't know what soda is, but at least the pop is just too much. I can't put sugar in my coffee anymore either. My body doesn't like it. Once I cut the sugar out of my coffee, I was a much happier person. I have a morning double double, and by 12 o'clock, I was taking naps. Anyways, I was looking and measuring that board there. Jumping back into SolidWorks here. I'm going to drop a new part into my open assembly here. Open this part. Take a look at my top plane. And make a little sketch here. Here I am, I'm pulling open a box, and striking a little center line, making the midpoint of that center line coincident with the origin so that this box is symmetrical. And let's see, I gotta change my units over to millimeters because it looks like this board is 100 by 100 millimeters. Change that over to millimeters. And we'll mark these. So I'm getting 100.5. I guess that's just because the way that they break these boards, right? Probably drawn at 100 millimeters, but however they're routing them and breaking them, just a little oversized. So I'll let SolidWorks know that they're a little bit over, so 100.5 millimeters. And 100.5 on that side. And let's extrude. This guy's, oh, how thick is our board, Marty? 1.6 millimeter. Nope. Okay, Delta 5 board. Ooh, we could probably even take a picture of this thing and drop it in there. It's really silly that they didn't put any mounting holes in this thing, isn't it? I don't know. Let's see, which way does this board go? This way if you're looking at it? Alright, so I don't think we need, do I need any of these other holes, Marty? I don't think so. Else we'll just locate off of there. I'll save that and drop that back into the assembly. And we got two of them side by side, touching each other. So let's bring these guys together, butt these two edges together, bring those two edges together, and select these bottom faces. Okay, there we go. Now we got like our two timer boards put together. Receivers. Let's just put the receivers right in this base part, shall we? Yeah, what the heck, right? Let's do it in here. So I'm going to extrude myself one of these rectangles, and then we'll take this rectangle and make a pattern from it. That'll give us our four receivers on each board. Very good there. And let's start measuring. This is harder with all the wires connected here, Marty. That's about 22 millimeters there. About 26 in this direction. 26 millimeters. And we don't really have the proper tools for measuring that, do we? Well, we can get on there. 2 millimeters down from the top. And I don't know, 2 from the edge maybe? 2 from the edge. Okay. And then our pattern spacing, I'll just say that what's nice is this pattern kind of stays together like this. So all I need to do is drag that over there and say that it's also 2 millimeters from that edge. There's our receivers. How tall are these guys?
Havlock 716 yo.
3.5 millimeters. They're poking up. All right.
Havlock 716 I'm in. That was a test.
Havelock, I'm in. That was a test. I'm glad that you figured it out. Havelock is all it was you just had to hit the follow button, or was there something else that had to be done there?
Tilsalence, what up, Havlock?
Let's see. We're gonna save this down on our streaming folder here, and I'm gonna go out to the interwebs and find a 3D model of this Raspberry Pi.
My quest bench now.
What's this?
Havlock 716.
In closure. How you spell it? Okay, out to the web. Let's see here. We'll try GrabCAD. I don't know if you guys are familiar with that website, but if you just gotta sign up with your email address or something like that, and then you got access to actual 3D models. It's mostly SolidWorks files, although they do have step files and IGES files and stuff like that. I guess it depends on the author, but it's like a bunch of like a community thing, kind of like Thingiverse, but Thingiverse would be your STL files for 3D printing, and GrabCAD is like actual SolidWorks files that you can go in and modify. They're better than your STL files, which you can't really go back and edit. Bring this over here. All right. Looking for Raspberry Pi. How the heck do you spell it? Like that? Raspberry Pi. Okay. Marty, Pi cases, Arduino stuff, displays, Raspberry Pi Model 3B. Marty, is this Model 3 Pi B Plus gonna work for me?
Smarky FPV, so much stuff.
Does that look right? Kinda looks like it's mostly the same. What's different on it? I imagine the important things like the mounting holes haven't changed between these two models with the B and the B plus, right? I don't see this module, this little Raspberry thing on this board here, but that's what we're doing.
Just came out.
Marty says this is the new one that just came out. I want it.
TV, oh my god, why does my voice sound like this?
Nope. So we're gonna download that Raspberry Pi model, and I think while we're in here, we need these little Arduino Nanos, right? Arduino Nano. Did I spell that right? Yep, it just doesn't know what the heck I'm talking about. Nano Shield. No Nano. That it? That looks like it, right? Pins like that. No, that's not right, is it? That's got the pins going the other direction. This one? Yeah. This one looks way over detailed. I like it. Let's see. Step files. Beautiful. Take them. All right, Smarky. Smarky says, why does his voice sound like this? Is there a live chat? Marty, what's available for live chat so I can like hear everybody? Is that what Discord is? I haven't looked into what Discord is yet. We used something called Zoom for the multi-GP chapter organizers meeting. That wasn't too bad.
Tulsalance, everyone sounds like Hawkins.
There we go.
Cram Nitram 1 Discord.
Discord. That everyone could be in there, and then like everyone could like chit chat and talk, hear each other. That would be pretty fun. Where's Andrews? I think this would be a lot more fun with him in here. That's for sure. Let's see. Anyone post back in Buffalo Multi-Rotor that we're in here? Where's Bob? Everyone sounds like Hawkins.
Tulsalance F. Andrews.
Oh. Digital silence.
Tulsalance I did.
Let's see here. Oh, we're here. Do I have my live stream set up where it's actually reading all the texts back into the stream? I know I looked at that. I don't remember if I set that up or not.
Tulsalance yet. Tulsalance S.
It is? It's reading the texts out loud back into the stream? Oh, so I don't have to... I'm being redundant by looking over to my chat window and then reading the chat. I did not realize that. Good to know. All right. All right, now we got our two parts here. Okay, now it should be good. GrabCAD. That's done. Yeah, so grabcad.com. Bunch of files that you can use. All kinds of cool stuff. Now we go. Oh. Okay, so now let's take and open those parts up and import them into SolidWorks. So our Arduino Nano, it gave us two parts, STL. So if we wanted to 3D print a little scale Nano, we would use the STL. But I want a parametric model, so we're going to use this step file. And it's just got to convert, run some diagnostics to patch all the little holes, and we'll be good. So she's got to reticulate her splines real quick. Holy cow. I guess this was the downside to getting that really detailed Nano. That's a lot of surfaces we're dealing with here. Maybe that was a bad idea to get the pretty one. I should have got the ugly one. That was a simpler model. Holy, we're still going. How do I change the voices and have it read other voices?
Smarky underscore FPV must be your internet provider.
Must be your internet provider. You know, they stink, you know? If I could only get Fios out here. Finally get rid of that darn Spectrum. Oh, sweet. Look at that. That's beautiful. Chip's even labeled. Chip's even labeled in the correct direction, Marty. Look at that. Crazy. Okay. No problems. Sweet. So we'll save this down as a SolidWorks file now that it's converted, and we can drop it into our assembly. All right. Drop these things in here. Oh, actually, I don't want two of them. Oh, I just want to make a pattern of them, right? That's right. That thing sits on there like that. And we'll go and we're going to mate this thing together. So that surface to that surface. Measure how tall, how far off these boards these things are sticking, Marty. 12.5 millimeters. Jeez. 12.5 inches, that's even worse. 12.5 millimeters. There we go. Better. Better get my units straightened out here. Options, properties, units, millimeters. Okay. Then are these guys centered up on these receivers?
FPV, that's what she said.
Nope. Why would they be? Marty, what are these little jumpers? Wow. Hold on. Let me show. We gotta show everybody Marty's jumpers here. Pop over to our microscope. Where are we? There's our little jumper. Everybody look. There's our jumper. There we go. Back to SolidWorks. What do these do, actually? Marty, what are the jumpers for? Do those, like, disable nodes if they're not working? The node's not working properly, you disable it? Can you, like, pull the power or something? I wonder what those jumpers are for. Let's see if we can get this thing located on the board properly. Distance there to measure.
Reset CMOs.
Reset the CMOS. CMOS.
Havlock 716 you gotta bail TNGHT. Stream won't stay running at all for me TNGHT.
It's about 2 millimeters back there. Something tells me whoever laid out this board just kept typing in 2 millimeters. Havlock need better internet over there. Stream's no good. Just, hopefully the stream's good for everyone else. I don't know. I've got the what do I got? I got the green light over here. No drop frames.
The power back feeds.
Let's see. Marty says. Well, everyone knows what Marty said because Stephen Hawking is reading it back, right? Marty said, I think that was the design intent, but the power back feeds. So if you pull that, there's power coming through these pins anyway, so the thing runs no matter what.
Jervon Haas YouTube is good.
These guys located. About 5 millimeters. Okay. There we go. Accept that. That distance, about 5 millimeters. Other direction. There. Okay. And then we're just going to make a pattern from that. So, pattern. Direction, I'm going to select the edge for the direction that I want to pattern in. And I say I want 4 of them. And the component that I want to pattern is this one. And I need my distance here. .24 millimeters apart. She's still running okay. All right, so that's that, and then we kind of need to mirror that pattern. I suppose would be the right thing to do. Sure, let's mirror it. And we'll use this little edge there as our mirror plane. And we're gonna mirror that guy, that guy, that guy. Oh no, our boards are effed. Oh, let's see. Gotta change our orientation, huh? Let's see, this way. Nope. Edit. There we go. Orientation 1. Orientation 1. Orientation 1. Orientation 1. There, that's better. Oh, Haas, what's up? Haas hiding there with us. Oh, awesome. We got 7 people over YouTube and 2 people sitting on Twitch. Pretty good tonight. All right, cool. There we go. There's our 8-node timer boards. I'm not going to bother with the resistors or anything like that. I just want the major components on this board so that I can lay out my box to put this thing in. What next? We got to drop in our Raspberry Pi. I can't drop the Raspberry Pi yet in until I convert it over from its original format that we downloaded in. Let's take a look. Where is it? Raspberry Pi Plus. Let's see if I can open the SolidWorks file. No, I cannot. Okay. That means it's a newer version of SolidWorks. So let's open the step file. Let it do its thing. Marty, do I even need these do I need these jumpers on there if they don't do anything, or is it better to have them on and not rely on the power that's being backfed through them? Or can we just probably just solder those, right? Just solder across those pins. Make them permanent. Diagnostics, sure. When you import parts from other programs and stuff, SolidWorks likes to run diagnostics and check for bad faces and holes and stuff in the model. If you had a hole in the model, like a missing face, you'd never be able to 3D print it because the software wouldn't understand how it's actually has any volume. That doesn't take too long for that diagnostic thing to run. It's not a terribly complicated part. But I suppose we do have a lot of programs running trying to do the live stream at the same time. What else is going on while we're waiting for the computer to play catch up here? And I enjoy some of my Earl Grey. And once I'm done with my Earl Grey, then I switch to this. There we go. What's different on the new Raspberry, the B Plus? What does that have that the that the one I bought doesn't have. This is just the B, Raspberry Pi 3 Model B. Is there built-in Wi-Fi on this guy?
Since the Nano
Okay,
is
here's our
softer,
diagnostics.
it's better just to pull it out than the jumper.
And you see it's found some
Load up Fortnite while you're waiting.
some problems during the import. And so I just hit this attempt to heal all problems. Load up around a Fortnite while we're waiting. Fortnite doesn't look awesome on this computer. I don't know how the kids play it with the bad frame rate. We're way past that. But we used to, what kind of frame rate did we have when Doom 1 came out? I remember that thing used to be like a slideshow on my first computer. For some reason, it played it for hours on end over the modem. Crazy. Never deal with anything like that. Be pissed off if you're not getting 60 frames a second, right? Poor kids over here on this machine. Slideshow and Fortnite. What are these things?
Keyboard wizard.
Oh, that off of there. Uh-oh, Marty. I don't know which pins. I don't know which way that goes on there. I guess it doesn't matter. I can pull that off. Marty, you're going to have to figure out how those go back on there. Looks like you're going to brown and red on that one. I'm going to pull that off there. That way it's easier for me to take a look at this guy. I was a keyboard wizard. Yep, I did not use a mouse in Doom 1. It was all over the keyboard. I'm yelling at my kids for doing the same thing. I mean, they're keyboard and mouse and everything, but their SD technique is way off, because their like index finger is on the W, and then they're like doing this like reach around thing with their other finger to get to the other keys. It's driving me absolutely crazy that they can't use the middle finger on the W key. That's bothering me a lot. But let's see, how did I use the Doom? It was AWSD this hand, and then I was on the arrow keys with this hand. I had the insert key, right? Insert key over here. I had control over here. Spacebar, shift control over there. It was fine. You didn't need a mouse back then. There was no aiming up and down in Doom 1, so there's no reason to use a mouse.
Tulsalans, no wonder why you got owned.
No wonder why I got owned. I didn't get owned. I own people. I own people because I could strafe just fine. You could strafe like that.
Tulsalans, wow.
Some of the other guys couldn't strafe. They didn't figure that. It took them longer to figure the strafing out. So you just run circles around them. I'm sure if I would have grabbed the mouse, I really would have been something. But I mean, that's why I'm like the top player in Battlefield right now. You know, it's all that hardcore training. Camera and display. Oh, okay. So these two like ribbon cable connectors. Is that what that is? This would be for a camera, this would be for a display. What goes in there? I mean, HDMI, that's obvious, but I don't know I don't know enough about these to know what goes in those two like ribbon edge connector things there.
An awesome medic.
I have an awesome medic in Battlefield. This is true. I can't say anything negative about that. I always have somebody by my side to bring me back to life when I get owned. Is there Wi-Fi on this guy? Right? Did we determine if the Wi-Fi is built into this and we can pull an antenna off of it? Or was that one of the other boards that we were looking at? Don't see It does have the Wi-Fi on it. Okay. And that's maybe this upper corner over here.
Tulsalans no Wi-Fi.
No Wi-Fi? Somebody says Wi-Fi. Somebody says no Wi-Fi. Oh no, that's Wi-Fi right there. Right? Yeah. Switch over. That looks that looks something like a radio right there. Focus that a little better. Am I correct, Marty? That looks like a spot for Wi-Fi. My little pen out, right? So this is like the antenna right now, right there. Something like that. That's part of the antenna. And to put an external antenna, I believe you put the like that UFL connector right here in this empty space. You solder that UFL connector down, and then right, you got to take this resistor off and move it over and bridge those two pads, right? So you're turning it. You got to take it off of there and turn it and head this way with it, right? And your UFL goes right there. I think that's right. Sure. We'll see if Marty concurs. Marty, do you concur?
It requires a
Looks
mod.
like SolidWorks has done its thing and fixed all of those faulty faces. So we're back in business. Okay, Raspberry Pi, save that as a SolidWorks file, and now everything will run faster. Faster, better, stronger. Okay, drop our Pi into our assembly here. Okay. We need to start locating this stuff in space here. Select my top plane and made it to there. And where do I want the right plane? Maybe I would do the right plane on this guy here. Next to select other button. There it is. Select other. Right plane. Mate. Go. And front plane. I want to lock onto there. Lock the front plane. There we go. That stuff's all fixed. Oh, frame rate's not happy with all those Arduino Nanos on there. Sweet. Okay. Alright, so you had this thing wired in over on this side of the timer. Right, so there are two little jumpers like that. Perhaps put it like that. Something like yep. Okay. And locate that. And set my like gap distance here, selecting these two faces, telling it that I want a distance between them of, I don't know, 4 millimeters. That looks good. All right, and then I'm gonna line up the two front edges of the board. Now everything is fixed in space, and I'm gonna save that assembly. And I'm gonna take a guess that this is way bigger than my 3D printer can do the way it is right now. I'm gonna just like start a little sketch from the top view and put a box around everything and see how big this box has to be right now. So 270 millimeters. What is that in inches? Let's see. Dual dimension. I want my dual dimension to be inches. Okay. 10.5 inches. I think my bed's like 10 inches. It would have to be like 2 pieces or something like that. Marty. Oh, what do we got here? Let's take a look. That looks like the Raspberry Pi pinout. All right. Very good, Marty. Let's see. Take a look at this. This is like 11 inches by 5 inches. That's kind of a good size box. Does anybody else have like a 12-inch a 12-inch print, a 12-inch bed on their 3D printer? I think mine is like 10 by 10 by something. 10 by 10 by 12, 10 by 10 by 10. I wonder what Quest has. Quest has a bigger. Doesn't he have a bigger printer? Those Felixes?
Totals negative.
Negative? You know, huh? You know they're not bigger. How big is your printer, Digital Silence? It's big enough, right? What's the bed size on your 3D printer? I'm gonna add a new part to our assembly here. And this is gonna be the beginning of our enclosure. Take our top plane.
Smarky underscore FPV, this is strange to me.
Smarky says this is strange to me.
Totals negative on that side.
This is drone racing, man. This is what it's all about. These nanos are killing me. They're making this thing way too slow. Okay, let's finish this operation real quick, and then I have to turn those off or something because they're killing me. That's going to be our box. Move this out of the way. And let's hide these for the time being. Give me some performance back here. Can I hide this whole thing? I can. Hide. Oh, so much better.
Cram Nitram 1. Some people are stacking the 2-timer boards.
Marty, stacking the boards. What is your thought on stacking those boards? Because my thought on stacking the boards is that you would have like a different threshold for pickup on your lower 4 versus your like upper 4, right? Am I not thinking about the way the radio waves come into this thing? Like, is that wrong to think that? And they'll all receive like an equal signal? Because to me, like if you take these and stack them on top of each other, your top board's gonna kind of block some of the signal for the lower board. I was thinking about maybe doing them like opposing each other, but the boards are square, so that really doesn't save me anything. I suppose the Raspberry Pi could probably go, could probably stack. Should we stack the Raspberry Pi? Put that like underneath it? Marty, what's going to be hot on here? Where's most of the heat going to come from? Maybe that's the way to approach it. Where's most of the heat coming from? Is it going to be that big chip that's on the Raspberry Pi that makes most of the heat? I should probably give some consideration, since if this thing's going to sit out in the field in direct sunlight and the box is going to get hot, I maybe should think about how that's going to affect this guy. I think that might have been one of the problems with the TBS timer. Um, it was kind of sensitive to heat when that thing's sitting out in the field and the sun is hitting it. That it can change over time.
Cram Nitram 1 yes, it might need a heat sink.
It might need a heat sink. Yeah. So I don't want to bury this too much where the heat's gonna get trapped, right? I'm gonna want this thing to ditch its heat. The immersion is completely sealed. There's no fans on it, which is very good. You know, like Scully was saying, it's not gonna sit there and suck up pieces of grass and crap from the field. You know, the whole thing is sealed, but it's one big huge chunk of aluminum. I imagine it itself is a giant heat sink. Unless, I don't know, unless the sun beating on it makes the thing hot and it actually works against you and you end up putting heat into it. I'll put this guy on the bottom here. Make this just a taller box. I don't know, to me, I think a shallow box is going to help me find cheap material in order to make this out of, right?
Matte fender mounted.
Like if I leave this laid out flat like this, I could get a piece of bar stock, right? Like a 6-inch by 2-inch bar stock would work. But if I stack them on top of each other, then I'm going to be looking for a piece of bar that's like maybe 3 inches. That might get a little expensive. I might know where to find some 2-inch bar stock. Mounted on thermal pads, right? Like transfer the heat from these chips like right into the aluminum enclosure. Try to ditch the heat that way, right? Ditch some of the heat down into the grass and into the ground and stuff like that. Hopefully that, like the damp ground, soak up some of the heat right through the enclosure itself. Not a bad idea. Let's see. This guy. I'm gonna take my hat off. Actually, getting a little warm in here. Okay. This is still an inch.
That thermal double-sided tape.
Let's edit this sketch here. Clean it up. So we're thinking maybe like a 12-inch chunk of aluminum. 5 inches. 2 inches deep. Okay. Start with that. I'm going to change this to kind of a wireframe so that I can see through it for a little bit. Delete that sketch. I don't really need that anymore. How do we want to locate this? We want it to be a certain distance. I'm not going to, you know what? I'm not going to use the connectors. I'm not going to use that network connector from Raspberry Pi. I'm going to end up using one of the locking connectors, the XLR style connectors. So I'm going to back this board up. I'm going to take that mate that I set up and delete it, and I'm going to go over here with it. Made it that way. Okay. That looks better. Let's start setting up our assembly mates for here. See, I selected the front face and the front edge of there, and I make a distance of, oh, I don't know, 10 millimeters. Sure. All right, and then for left to right, I think I want to use what's called a width. Can't say that word. Width mate. So that's, I'm going to select these two faces and make them kind of like symmetrical to those two faces. Okay. Now I just need a height. I think that's going to be how high my boards are off of the bottom. So we'll select that and that and do a distance mate. So distance. Oh, 10 millimeters again, but in. Oop. Oh, I hit the wrong button. There we go. That's the button I'm looking for. 10. No, what's the standard standoff? It's like 6 millimeter. Let's make that 20. Yeah. All right, so that's gonna be like a big chunk of aluminum, right? Then our like, got our finish line is like a stripe right across there, right? So set it up on the finish line. Our little row of receivers, that's like our finish line there. You pass over that line, that's gonna be when you're the closest to that receiver, and your RSSI should peak right there. I got another question for you, Marty. I don't know how good you are with radio, but if we took this and right, we're gonna hollow this box out. So I'm gonna make a cut real quick. This is an extruded cut. Like that's gonna be my. Actually, let's just make the wall thickness even all the way around by doing an offset. Offset, 4 millimeter thick wall. Okay. That looks thin. 6 millimeter. Yeah, that looks beefier. Okay, and then we're gonna dive in here. Offset from the bottom by 6 millimeter. 6 millimeter. Okay. What happened? I did an extrude and not cut.
Cram Nitram 1. If you check out the Delta 5 Race Timer Facebook group, there is a number of different boxes people are making. There's one from the designer on Thingiverse.
I don't need this to be transparent anymore because we're hollow in the middle. Cool, now we're a box. So Marty, I think what I was gonna say is like, if you made the top aluminum as well, but then just made like a slot over the top of the receivers, would that attenuate the signal because you're only letting in you're only letting waves in that are lined up with that slot? I don't know. That was rattling around in my head. Is that, I don't know if that would be the case or not. I think we're too, we don't need to be 2 inches tall, do we? Let's see. If you check out the Delta Race Timer Facebook group, there's a number of different boxes people are making. There's one from the designer on Thingiverse. Like, I know everyone is lining these things with copper or aluminum foil, right, to help reject the like stray signals. But can we make the top aluminum as well and then only give ourselves like just a slot to let the radio in? Or would that like make all sorts of crazy, ridiculous reflections inside the box and make this whole thing a big nightmare? Marty, I'm going to leave that totally up to you as to what we do. It's your call. Default display. 2 inches tall. I think we can reduce this. Let's see. Our height can be. We'll bring it down and leave ourselves like enough room for like a 1/4 inch piece of polycarbonate to sit inside of there. And let's see, I guess we continue editing this part, and we can build in our standoffs. So I'm going to extrude some circles lined up with our pads here. Lined up with our little holes in the Raspberry Pi board. Okay, so the standoffs will be integrated right into this enclosure. I'm going to make all these circles equal so that I only have to dimension one of them. And let's say that's like 6 millimeter. It is 6 millimeter. Perfect. Okay. Exit that sketch, and I also want them 6 millimeters tall. There we go. And if I open this part, we'll see that like there's our box hollowed out, and we got our little standoffs that are integrated right into it.
People make Faraday cages from chicken wire.
Don't think it would work. People make Faraday cages from chicken wire. Do you make a Faraday cage from chicken wire because it's cheaper than making a cage out of like solid aluminum? They both would do the job. Let's see. Little tapped holes here. Can M3 pass through this hole? No, it cannot. That's not a 3 millimeter hole. What the heck, Marty? Why'd they make that such a small hole? It's like, let's see, select our tapped hole. Is there 2.5? Sure, 2.5. Is 2.5 common enough for me to use 2.5? I think so. I don't want to use like an uncommon fastener that's going to be like, it's going to be impossible to find. Let's place these things. Snap them onto the centers of those little standoffs there. So those will be our little tapped holes that we screw down into for that. But our wonderful Delta 5 timer people did an awesome job on this board, but did not give me any mounting holes to work with. So, what should I do? What should I do, Marty? Best way to do this. I don't want to just make a little standoff, do I? Because if it wears through the masking, right, and hits a trace, we could be in trouble. Doesn't look like there's any copper up here, is there? No copper up here, but underneath the underneath those receivers. Or is it solid copper? I don't think there's any copper there. I think it's 0. Yeah, I don't think there's any copper there. So if I make a boss that runs right here, then we could use like some double-sided tape or some of that thermal stuff to go right there. We just kind of need a screw hole or something. I don't know, Marty. What kind of creative things do these electronic people have?
Like some people just drilled holes.
Looks like people just drilled holes, huh? Where would you drill a hole where you're not gonna hit anything? Problem is they took everything so close to the edges that I don't know where to put it. I could use the battery negative holes, right? Marty, do you see any problem with like putting a screw in each one of these battery negative holes where the XT60 thing would mount? How would that work? Would that work all right? Then I have to model where that hole is. First, let's put our like little pad thing. So like this guy would be there, and it would be like 6 millimeters tall. And our boards could kind of rest on that thing. right? So if I do a little cutaway view from the side, right, we'd kind of put that boss right there, and it would support the edge of the board right there. Yeah, we love double-sided adhesive, right? We just have to give ourselves a little bit of room for that double-sided adhesive. So instead of 6 millimeters, I gotta back that off just a touch and make that like 5 millimeters so that we got room for our double-sided tape. Yeah, there you go. Move this over. Centered up underneath those receivers. Not too bad. Not too bad. Okay. What else do we need? We need our connection, right? So let's see. We need to pull up one of these guys, one of these new trick connectors that I like so much. Go over to Ethercon chassis connectors. And we'll put one of these on there. I think these things can be there we go. I like these ones. These ones here are waterproof. Well, not totally waterproof, but pretty darn good. Shielded feed through. What do I want? IDC termination? What's that? Is that where you shove the little wires down in? If I do feed through, that's just yeah, whatever. I just looking for the model. That's really all I want. 3D model. That doesn't know how to use SolidWorks to open that. SolidWorks. Okay, let's open that model up that we just downloaded there. What did I just download? It's called FDX. This guy. Oh, I do need import diagnostics. Here's what I was talking about with a bad face. You see how that came in all jacked up. Not happy. So we run some import diagnostics on that to fix that. Hopefully it can find a solution here. There we go. Perfect. All right. Save that back down as a SolidWorks file and drop it into our assembly. Okay, so there's my like waterproof little Ethernet connection so that when we're out in the field, we can plug it in, and once everything's plugged in, it's got like a little gasket in there. Everything is sealed. It can rain, and we don't have to run around like idiots getting everything protected and covered up. This thing can go sit in that field and get rained on, and it is not going to matter one bit. But this is the lovely thing about modeling everything in SolidWorks ahead of time. This guy is too big to really fit in there. So I gotta think about where exactly I'm gonna put this guy. If I turn the corner and put it on this face.
Cram Nitram 1, how about dovetail clamps on edge of the top and bottom of the board?
Poking the board that way too. Dovetail clamps on the edge of the board. Yeah. I was kind of thinking the same thing, Marty. But when I'm looking at the edge of the board, I'm just wondering, does that get too close to the like actual antennas of these receivers, right? It's like a millimeter, right, between that antenna in the edge of the board. So is that a good idea to do that? Or does putting metal that close to the antenna affect anything? I'm sure if it touches it, that would be a problem, right? Or is it not a problem? They could kind of share a common thing and it wouldn't. Well, no, we don't want that to get grounded, right? We don't want that antenna to end up grounded, which it could be, right? If I put a screw in there, the whole thing's grounded and then nothing's going to work, right? A TPU dovetail, how about that? 3D printed TPU dovetail. That sounds like something, that sounds like a job for Smarky. If he's still in here, that's what he can contribute to this little project. I think I'm gonna slide this whole thing down. Right. So if I look at my mates, I'm gonna delete that with mate. And if I slide everything down,
Smarky_FPV sure what the hell.
then I can put my
connector in. Nitram 1 or
That'll give me enough room. Okay, so let's get our box in position here. Say 4 millimeters off that wall. And then that'll give us room to put this thing in there right on the edge, kind of like that. Cool, that'll work. And then we just have to like come out of the back of this, turn around, and go into the board. Perfect. Turn the board sideways. I don't know. We'll go with it like this. I gotta update my little standoffs here. Not edit this in context, so they're not going to update automatically. I'm trying to move quickly. But had I locked those earlier, save some time. Okay. Standoffs are back in the right place. Now we got this thing to deal with. Bad. What size hole do we have to do? Pull up our drawing from Nutrick here. Okay. Right here you can see our hole pattern that they call out. It's a 24 millimeter hole. I have to edit this part and cut a hole. Place it in the general area that we're in. And call this guy 24 millimeters. Okay, next. All right, there's our hole. About where we want it. Open our part and edit that sketch and just kind of lock things in. So I'm going to say it's about that far from the bottom and about this far over from the right. And I'm just kind of making those nice round numbers. And then we need a hole pattern to go with it. So let's do some tapped holes. Go back to our drawing and look at what we got here. Those are M3s that'll fit through there. So let's pull up our M3 tapped hole. And we're going to go through that face and stop before we hit that back wall. I'm just going to place one hole, and the rest of them are just going to be a pattern based around this hole here. So I just drew two lines real quick so that I can do two mirror operations. So I took those two holes and mirrored them, and I'm going to mirror those two holes like that. I got my 4 holes. I'm going to refer back to my drawing. I can see that these holes are 19 millimeters apart that direction. Two and say 19 millimeters. Then back to our drawing. These two holes are 24 millimeters apart. Mention those two holes and 24 millimeters. Accept that. There we go. Got enough room. Looking good. Back to our assembly. And this guy's kind of floating in space. But now we can lock it down. So we're gonna grab those holes. And that we're actually screwing it together. We did a mate there and it's stuck there. Line those two holes up. Those two holes up. Now it's fully locked in place. Cool. So we're going to power this. We're going to power this box with power over Ethernet. That way it's just a one-wire connection into this box. Let's see. Little Delrin holder. Yeah. Okay, so said, do these receivers get hot? Or do just transmitters get hot? I want to say the receivers get hot as well, right? Don't the modules and the goggles usually get hot? I think we should probably throw fillets in these corners too, right? Before we get too carried away.
Tram one, they get warm.
Use a 1/2-inch cutter. Yeah.
Matte fender, they'll get warm.
See, they get warm. Yeah, fender thinks they'll get warm. I would agree. They probably are gonna get a little toasty. Okay. So we'll machine out our aluminum box like that. Let's use a cutter with like a corner radius of like 30. Make things go nice and easy. Work everything down there. Yeah, that'll look pretty. Before that, we kind of want, what do we want? We're gonna hold these with an edge connector, right? We're gonna hold these with a little dovetail that Smarky will print out for us. See how else let's make a new part for that. New part. Our Smarky dovetail.
Smarky FPVIM.
Yep. Yes, you are. Some sort of like I'm thinking this is what the profile looks like. Something like that. This is 6 meters. Change our units over. Okay, and then that. I don't know, that's like 4. This is the thickness of our board, which we measured at like 1.6. These are just kind of arbitrary, but let's say that overhangs by 2 millimeters. And we can kind of like push it into place. I don't know if this is gonna work.
Cram Nitram 1 make the bottom part of the box and the top be the non-conductive material.
Yeah, some non-conductive material. Here's kind of what I'm thinking. If we make this thing like long. Right, so what if we did this? Top plane, put a couple more pieces together here. Okay, so like that would be like our little mounting tab. Mirror that little feature. Other side. Hole in it. Our clearance hole for our M3 fastener. M3 fastener. Through the whole thing. Right there and right there. Okay, so like if Sparky prints this little guy out of TPU, put these like on the top and the bottom. That like that give us what we need? Did that do the trick? No, something not terribly complicated, right? Like that, TPU part like that. Hold that part in place for us without it wandering off. We have to modify that. That's clearly not gonna work the way I drew it. Bring this in. That we're gonna have to go back and modify that some more. But yeah, right. We do two of those. That'll keep our boards from going anywhere. Then we just kind of need a stop, a left and a right stop, in order to keep the thing from sliding out of its holder. All the TPU is gonna have a good grip on it. That stuff's pretty grippy. Let's see, let's throw some of these fasteners in here. Let's see, metric bolts. Socket heads are our favorite. Oh, it automatically knew that we were trying to use it 2.5, and that's probably, I don't know, like a 6mm would be good for the length. And these guys would be countersunk, right? That's got to go the other way. Let's see. 8. Good. Let's flip this guy around because she got put in there the wrong way. Flip alignment. go. Beautiful. So those would be the fasteners that we need so far. Oh, you know what? I don't want TPU in there. Why? Because the melting point of the TPU, that might make an awful mess. Right? I could be wrong. But I kind of recall getting TPU hot. It gets messy. I don't know. Is this board going to get hot enough to get that TPU all sticky, melty? What's your feeling on that? We need some sort of gasket and stuff on this box. Let's see. Break these edges on the outside so that she's pretty and soft. Come around and champ for it. Just a bit of an edge break here, right? 30 thou. 30 thousandths. Break those edges. And we need our like cover for this thing. So here's where I'm interested in like just a piece of aluminum for the top. Piece of aluminum for the top with a window cut in it. Marty, what say you? What say you, Marty? Let's throw it in there. Let's throw the part in here. Okay, how big is this guy? This guy is, what was it, 12 by 5? Let's dive into
Cram Nitram 1A piece of phenolic would probably be ideal.
Piece of phenolic would be ideal for the top of it. Hard piece of phenolic. Alright, we gotta think of things that I can easily obtain, right? Piece of phenolic might be ideal, but the ideal piece of material is a material that
Cram
go out to the barn
TPU rail.
over the TPU rail, a piece of phenolic. So that what would that would be like your like a retainer for the TPU, a washer for the TPU, non-conductive material to hold that down. This is my lid that we're making here.
Cram Nitram 1 the top probably just.
Six millimeters. Like 6.5 millimeters.
Cram Nitram 1 acrylic, polycarbonate, or PET.
All right, I'm gonna make like a little stair step on our lid. And this little stair step will locate the top of the box. I'm gonna have to fillet these corners. Because of the radius of our cutter. Okay, so there's that. And then we want to break all these edges so that we're not cutting slicing our hands up. Our edge break's gonna be like 30 thou. And that will be the top of our box. All right, and we can put like a gasket or something between these guys. Now we can put a couple screws in the corners and stuff. There we go. So there's our top. Our top can kind of sit in there like that. And I'm thinking that we blast a window into this part, right? Because that's a solid, like a solid aluminum top. And then I extrude a slot, right? So on the CNC, we'll come in and just make a slot that's above the top of these receivers here, like so. And that'll be like the little pathway for the radio signals to come in. This is definitely gonna work. Yeah. Perfect. Right, so there's our little window. For our material, all right, we need like a little piece of polycarbonate in there. So I'm gonna just like, let's see, offset this thing. 1. And go 0.1 deep. Ah, what did I do? I did a extrude instead of a cut. Okay. There we go. Now we got a little stair step in there. And I don't like how thin that material is right there, so let's just kind of
Cram nitram 1 air
back
holes.
that off there. Air holes. Nope, no air holes. This has to be completely contained. Don't want water to go in there. No water allowed in here. I'm gonna break this edge, but not with 30 thou, just a tiny little edge break on there. Okay. There we are. So that's our little window in. Marty, it's, you know, always the electrical guys that are giving us mechanical guys a hard time about their electronics. It'll be fine. Plenty of aluminum to sink the heat, right? Perfect. All right, now we're just gonna make our like last part, which is our window here.
Cram nitram 1 you get condensation.
Come in and find that loop and offset it by just a tiny bit so that the material will push in there. Go. And let's say that's a 1/4 inch piece of polycarb. Okay. Edit. Let's see. Material. Polycarb. Go. Our window. Beautiful. Beautiful window. You get condensation. You do get condensation. They had condensation inside of the immersion timers. I saw that on Facebook. The whatever the humidity is was in the assembly room over in Hong Kong there. Yeah, they definitely had some moisture in the first ones, but they have, I believe, fixed that, so you don't have like I've never had condensation in my immersion timer, so I don't know. Are they in a really dry room when they do the assembly? I mean, is Does sealed mean sealed? Does water eventually get in there and then you put it in the sun and you get condensation? Oh, but I do remember seeing some posts on Facebook with the little. It wasn't a lot, but you would get a little bit of condensation in the corner of the windows.
Purged with argon.
Purged with argon? I don't know. Is argon a gas with like large molecules so that they don't escape? I don't know. I'm editing this part really quick because I want to put the step in this thing as well. One. What did I do? I keep hitting. Oh, I did. Cut the wrong side. There we go. There'd be our little polycarb part, right? And we'll silicone that right into the hole. Is polycarbonate transparent to radio? Oh, or is it black? Is that black RF? But we'll find out, right? If we have to put our gain through the roof in order for this thing to read anything. Hole patterns. No, put those in. Put our hole patterns in here. No. Screws in our boards. There we go. Delta 5 timer. Then we can anodize these things and engrave them, right? LFPV Delta 5 Pro timer. However, not for sale, right? Open source project. So, open source enclosure. Top here. I think the final things for me to do on my own time is gonna be just to give myself some screw holes and maybe a little slot in order to put some silicone in there for a gasket. And yeah,
we'll just pack it with
desiccant. That's easy enough. Throw a little desiccant pack in there. Should probably be good for a couple years, right? And we're probably talking about just whatever humidity was in the air when this thing gets sealed up, right? I mean, I could throw the welder, throw the welding gas in there. You know, that'd be nothing to just stick the TIG torch in there, right? Stick the TIG torch in there before we screw it together. Get some of that air out of there. Sweet. Something that I want though that the immersion timer doesn't have is like this thing should be like a cheese plate. This thing should be covered in quarter 20 holes, like blind holes that don't go through, but just everywhere on this thing, so that we can use all our kind of standard film gear rigging and stuff like that to mount this thing in funny places. Maybe I'll make this wall thicker and put like 4 through holes in the corner, and give myself a bunch of 3/8, 16, and quarter 20 tapped holes in this thing so that we can mount it to our gates rather than just throwing it on the ground. Because when we throw it on the ground, the timer sees everything above it, right? But if we mount it on the gate like this, facing downward, right? Put a bunch of quarter 20 holes up here. Mount it to the gate looking down. That way when the stray quad goes over the top of it, hopefully it won't pick them up. You know, with the gain set properly, it should just see the quads that are coming through underneath it. So that'll be the last bit. But we're almost at 2 hours, so won't bore anybody too much with the details of drilling 100 holes in this thing. I think that's pretty good. Put that lid back on there. Cross section there. There we go. Got the start of our enclosure there. I mean, we could 3D print this thing. I kind of want to get this thing on the mill and blast it out.
Fender until it gets whacked at about 70.
Fender says until it gets whacked at 70. Yeah. Yep. All fun and games until somebody flies straight through your timer and cuts it in half. So I'm looking at Quest. Cut our gate in half right through the Schedule 40 PVC, man.
Maybe send me the file.
Oh, these things have a ton of power. Right? You can look up the formula, but take 500 grams at 70 miles an hour and see how much energy that is. It's right up there with bullets. Not high powered sniper rifle stuff, but handguns and 22s.
Matt
It's
Fender
like the same amount of energy. It's crazy. Yeah, after Quest flew straight through that PVC, I had to know, so I had to do the math, and yeah, it's pretty impressive. Right? I could just imagine what happens when you get a quad up to 200 miles an hour. How much energy you're talking about? Oh, what was the other guy on YouTube that was just talking about this formula? Right? So you got mass times velocity squared, right? So you do more damage by doubling your speed than you do by doubling your weight, right? Because the way that formula works, because the velocity is squared, right? So if you take your quad and you put a bigger battery on it or whatever, and your weight goes up, that's not as big of an increase in energy as like going twice as fast. Going twice as fast is like a huge increase in energy. Squared, right? All right, cool. I'm gonna wrap it up there for tonight. Let's see, what do we got? Tomorrow's Friday. I've got to be here until FedEx shows up, and then I'm going over to the track. Let's see.
Matt Fender, yeah.
I'll plan on getting over there at 7 o'clock tomorrow night. I know a lot of guys are down in Toledo, and I don't know that they're tuned in because there is probably all kinds of mayhem going on down at the Toledo show. But hopefully all of our friends down there are having a good time in Ohio. I'll miss them this weekend. They're going to miss out on their participation points on Sunday. So this is your chance to pull ahead of Stewart there. I don't know, we're back on track. We'll have our races on Sunday. I'll be at the track Friday night if anyone wants to practice at 7. And I'll be there Saturday at 4 just for our open flying and screwing around with the track. Like I said, I got another computer over there. I Got more video equipment over there. I've got the Night Owl DVRs and stuff that I'm starting to hook up so that we can like see all the video feeds at the same time. So I'm doing my thing over there. Anyone's welcome to join me and hang out and fly over there if they want until the weather gets better. Oh, Saturday. Yeah, I might not be there Saturday. I'll post in the Facebook group. We've got a movie shoot on Saturday, and I don't know what time it's gonna wrap. So if it wraps early, I'll be there Saturday. If it goes late, I'll just keep everyone posted. We'll head over there afterwards. So cool. Sounds good. Hey, thanks everybody for popping in and joining me. Marty, Bender, Smarky, Oss, Digital Silence, all you guys. Thank you. And I'll see you over the weekend. All right? Later, guys.